Hello and welcome to our SPCCIA2 video, which has been done by our group. The names and roll numbers of our group members are given in this slide. The topic for our IA2 is implementing Lex YACC for identification of different types of SQL select statements. Now, to before implementing Lex and Yacc, we need to understand how the SQL parser works or functions. SQL parser is used to parse SQL statements. The flow chart on the right shows depicts the flow of different stages or steps in parsing the SQL statements. Firstly, the SQL statement has to undergo a syntax check, followed by a semantic check and a shared pool check. The syntax check, semantic check, and the shared pool check are what comprises the procedure of parsing. After the procedure of parsing is over, it can either undergo soft parsing or hard parsing. If it's a soft parsing method, then it can directly be executed. But if it's a hard pass, then the parsing is followed by optimization, where generation of multiple execution plans takes place. After the code optimization, row source generation takes place, in which the generation of query plan takes place. Finally, it passes through the execution phase. Since syntax check and semantic check are the major two steps in parsing, we first understand what is syntax check. In syntax check, a statement that breaks a rule for well-formed SQL syntax fails the check. For example, if you can see below, for the given SQL statement, select star form employees. Notice how the spelling of form is different. It should be from, FROM. Hence, the parser returns error at line 1, and it returns the error that form from keyword is not found where expected. Now, the semantics of a statement are its meaning. So, a semantic check determines whether a statement is meaningful. For example, in the SQL statement, select star from say a table named non-existent table. Now, this table is not existing. Hence, the parser returns error that table or view does not exist. Now we move on to the implementation part, which will be covered by Harsh Gupta.
For implementing Lex and Yacc, we'll require a few softwares that most of us would not be aware of. The Lex code will be written in the Flex software. Bison is used to write the Yacc code. This third software is a complete IDE which gives us the option to use command line or a well-defined UI to execute the code. We'll see these softwares at work in the next section. Most of us would not be aware of what Yacc is. Yacc is a compiler. A compiler is a program that takes as input a specification of a syntax and gives as output a procedure for recognizing that language. This is also called a parser generator. Yacc is a LALR1 parser generator. LALR1 means look ahead, left to right, rightmost derivation producer with one look ahead token. Yacc was originally designed so that it can complement Lex. Yacc code is divided into three sections. The definition part, which includes information about the tokens used in the syntax definition. The rules part which contains a grammar definition in a modified BNF form. And the auxiliary routine part, which contains only C code. It includes function definitions for every function needed in rules part. We'll understand this better when we take a look at the code.
Now we move on to the code and output part of our program. Our program has been implemented using Lex and Yacc, which are tools. These tools can generate program fragments that solve the task of reading the source program and discovering its structure. Lex, which stands for Lexical Analyzer Generator, splits the source file into tokens, and Yacc, which stands for yet another compiler, finds the hierarchical structure of the program. Now we take a look at our Lex file, which is stored using the file extension .l. The structure of a Lex program consists of three sections: declarations, rules, and auxiliary functions. Now, the highlighted part is what is the declaration section. The declaration section is further divided into auxiliary declarations and regular declarations. Uh, this part is the auxiliary declarations part, and the two lines alpha and digit are the regular declarations. Now, after the regular declarations, we have the rules section. Rules in Lex programs consist of two parts. The firstly the pattern to be matched and the corresponding action which is to be executed. In our program, since it is an SQL parser, uh, the pattern to be matched are SQL statements like select, distinct from, where, etc. And upon encountering these statements, the action to be performed are given on the right. Also notice how the pattern to be matched is specified as a regular expression. Lex generates C code for the rules specified in the rules section and places this code.
Hello. Now let's understand YACC program for select query. Full form of YACC is yet another compiler. This file has entries in all three sections of a YACC grammar file. The three sections are declaration, rules, and programs. Declaration section is highlighted right now. Declaration section includes IO header files. It also includes global variables token that are used by the parser, operators and their precedence. Now let's see the rules section of YACC grammar file. The rules section of YACC grammar file is highlighted right now. The rules section defines the rules that pass the input stream. The rules are basically the switch cases which identifies each token and their precedence and generate the desired output, that is input accepted or throws an error. Now let's see the program section of YACC program. The program section is highlighted right now. The program section contains the following subroutine. Because of these subroutines are included in this file, we need not use YACC library when processing this file. Main calls YYPass subroutine to start the program. YYError, an error handling subroutine only to print syntax error message. YYWrap, the wrap-up subroutine returns a value of 1 when end of input occurs. Now let's see the execution of Lex and YACC program. Since my Lex and YACC file are present on the desktop, I will navigate onto the desktop by using cd command. To process Lex file, the command is lex filename.l. Here my file name is lex1. Therefore, I will write lex1.l. As you can see, lex.yy.c file is created. Lex.yy.c is C language source file that the lex command creates for lexical analyzer. To process YACC grammar file, we use -d optional flag. So the command is yacc-d filename.y. My YACC file name is yacc1. Therefore, I will write yacc-d yacc1.y. As you can see, yacc1.tab.c and yacc1.tab.h is created. yacc1.tab.c is a C language source file that yacc command creates for parser, and yacc1.tab.h is a header file containing defined statements for the token used by the parser. Now to compile and link to C language source file, that is yacc1.tab.c and lex.yy.c, the command is gcc lex.yy.c yacc1.tab.c -o lex yacc. Now here lex yacc is executable program file that will be generated after execution of this command. As you can see, lex yacc.exe is generated. Now let's execute lex yacc.exe. Now let's try different types of select query. Let's start with the basic one. Select star from student. The result is input accepted. Let's try another one which is slightly complicated. Select name, address from employee where age is greater than 20, grouped by name having age less than 40, order by name in descending order. Input accepted. I hope you understood the code and the implementation process of Lex and YCC program files for different types of select queries.
Hence, in this presentation, we have seen Lex and Yacc implementation of SQL select statements, and we have also created our own validator of different types of statements. With that, we conclude the presentation. Thank you.